answer as you can.
Yeah.
Yeah.
I think that's
It's a very loaded question.
Yeah. How are you feeling? Okay.
Yeah.
And if you're feeling okay, that's a 10 out of 10 right now.
It's the weekend thing, it's all the parties tonight.
That I am looking for.
What's like?
It's the sun above.
Maybe it'll.
Okay,
I asked Neo.
we can get started. This is Weather Watch for the last day of February, the 28th, day of the solstice party. We'll take a look at what's gone on this past week. I'll let this restart here. You can see just watching this once or twice, there's been a lot of little systems, disturbances that have moved over, especially the central United States. Some more interesting weather off the East Coast. There's this system that moved over Florida. There's been torrential, just ongoing rain over the west. As you'll see in this loop, there's one nice system. See, moves on shore right in its wake. Here's another one that moves on. Nice development over the eastern United States and then into the Atlantic there. And you can see that produces a cyclone that's still sitting over Greenland. I'll point that out later. Over us, we've had some precipitation, but you'll see none of it is as organized or as interesting, you could say, as the bigger swirls. We've just had this like mess of just moisture moving over. This is the one I wanted to point out. Look at this development here. You can see this cloud head that's in Greenland stretches all the way down south of Bermuda, and that's still, and then it hangs over there. So we've had weather, we've had rain. After a colder week last week, it's been much warmer. We haven't necessarily had nice systems, but that should change here going forward. Another thing I want to point out, you can see all the cold air that I've been harping on for a while. You can see it's largely in Canada, so it's been warmer. Each of these pulses is nighttime cooling, and then daytime heating. That has not made its way into the United States, which is one of the first times all year we've had that, where the really cold air overnight has been in Canada. And that's partly a function of all of this warm air has kind of eradicated our snow cover. There is still snow cover, but the cold air is just largely confined all the way up north into Canada, right around Hudson Bay. But you'll see right at the end here, some indication that part of the cold air is beginning to make its way towards us. Could we scoot forward towards the end of this loop? I'll point that out. So you see it's been warmer, it's been really nice this week, but the indication of what's happening is right here. Oh, maybe I'm a little too far. If we keep going forward, actually, sorry. Yeah, here we go, it's this system right here. You can see it's some cyclonic rotation around it, but you'll see it's dragging cold air, these brighter yellows and greens behind it, and that's our next weather maker, and it looks like it has some low-level clouds. We'll take a look at the current visible satellite, but that's essentially the cold front making its way through portions of North Dakota, South Dakota, essentially all of Minnesota, and half of our state here. So if you were outside, congratulations, because it seems like it's going to get much colder just a couple hours here. And if you go back just a little bit, please, I'll point out that cold air. You can see it particularly notable on the western portion of Hudson Bay right here. That's all that cold air being dragged down into the system. So I don't know if we'll get any precipitation out of this, but it looks like there's cold air in its wake here. One thing, if we can loop this again, let it start. So it was really cold February 20th over the Dakotas, Nebraska. We were cold too. By February 25th, which this is February 24th, I'll let this play here. By February 25th, in the daytime, there were 70s recorded in Nebraska and South Dakota. So that is some of these places like Broken Bow, Nebraska, which is essentially, if you take Nebraska, go exactly in the middle, that's where Broken Bow is. Valentine, Nebraska, I pointed that out at Valentine's Day. Both of those places got down to minus 33 on February 20th. 5 days later, about this time, they were in the 70s. So that's a 103-degree temperature difference over 5 days. And you may think, oh, that's pretty cool, that's significant, right? However, if you are from Montana or just know general weather extreme records, which I don't know if you do or not, there is a town, could we go to a time where Montana is not cloud covered? if that's a time.
Before or after?
Before, it looks like. Before this little system moves here. Just step back. Yeah, this will work. So here's Montana, right here. A place right around this location is called Loma, Montana. One day, January 15th, 1972, 104-degree temperature swing. One day. It took 5 days in South Dakota, Nebraska. This was one day in Montana. So can we go to that link I pulled up? Imagine that, 103-degree temperature difference. Here's the person that recorded this temperature difference standing by his co-op. So this is an article from Weather Underground. You can see the morning, so morning of January 14th, 1972, it was minus 54 Fahrenheit. This person woke up and recorded that temperature. He went throughout his day, it was really cold, and then he says shortly after midnight, there was a howling wind, so this is not even within 24 hours yet. At midnight, the temperature was 34 above zero. So 9 a.m. to midnight, and then by 8 a.m., which is 23 hours from when he last recorded his observation, temperature was positive 49. So it went from minus 54 to positive 49 in one day. And if you see, if we scroll down to this map, this was the weather conditions. Unfortunately, I couldn't find the archive. I wonder if that's a function of what's going on at higher levels, but this is the weather map, the surface weather map. You can see there was a big Arctic high sitting over Montana and essentially all of the Central Plains. What happened is during the day, these Fane winds or Chinook winds came over the Rocky Mountains here. Loma's about just in the lee of the Rockies. Temperatures raised 103 degrees, one day.
Wonder how deep that cold air was. I mean, that must have been
I know.
an inversion.
Guaranteed that this is just at the surface, yeah. And I don't know because I couldn't find the upper air maps, unfortunately. I just was going off this. But here's your Friday fun fact. This is what I spent my morning doing. So Chinook winds. Chinook is the term in east of the Cascades. Chinook, so chin over here, shin over here. They're named after a tribe in British Columbia that knew when there was these warm winds that came off the Pacific, temperatures would warm up. And so that's the association where people east of the Cascades then knew if there was winds coming over the Cascades at a certain angle, and temperatures were going to warm up. And so that's the association there. They are not directly called, I always learned Chinook winds mean snow eater because they're so warm. That is not the case. They are named after the tribe in British Columbia, and they were just known as snow eater winds. So they've been known a long time to produce crazy temperature swings. Portion of this warm-up was a function of those winds. It just wasn't as dramatic as the single day in Montana. And then these same winds, here's your last fun fact, same winds in Rapid City, South Dakota right here, produced 49-degree temperature change in 2 minutes. The temperature went from -4 to positive 45 in 2 minutes. That was so extreme that windshields cracked because the temperature changed so quickly. And there was such a difference in the moisture content of the air that they also froze over because it changed so quickly. Yeah.
In 1994, we're driving across from Seattle to Wisconsin to start living here.
Okay.
We stopped in Spearfish, South Dakota on
Yep.
purpose
Yep.
because I knew about this.
Mhm.
And so we go into a place to have lunch, and 19-year-old, 20-year-old waitress comes by and I said, "Do you know your town's really famous for something?" And she says, "Oh, you mean that temperature thing?" I was so thrilled. That made my
That's
day.
pretty cool. Yeah.
She actually knew, and she
Good.
had no business knowing that.
Good.
So
Yeah.
that was cool.
That's awesome. Yeah. Imagine being outside and all of a sudden -4 to 45.
Yeah, incredible.
I'm sure there was somebody who was outside on a walk with their dog or something. Just crazy. Yeah.
Yeah.
It's like -30, -40 in this location for months over the winter. So we just saw that. And this was 1970, so I'm sure they were more accustomed to colder weather, I would think. But, so not as dramatic, the warm up in South Dakota and Nebraska, but Loma, Montana, there's your fun fact, right here. Population of 82 people, so
This was one of the coldest winters ever in the 850 Milwaukee Cold War, too.
that makes
It was
sense.
a
Yeah.
couple of weeks before Nixon went to China, the whole thing, so.
And I forgot, if we go back to or scroll up, I think, to the last portion of this. I'd don't think it covers it here, but, so the temperature rose to 49. These winds stopped, and shortly after it was back near like 0 degrees. So this wasn't a sustained warm-up, it was just one day, you get these winds. They were known to destroy the snowpack, and then they calm down, and you're back into the cold air. So, and it says, imagine that spread, that's like going from 0 to 103 degrees, obviously, or 17 degrees to 120 in 24 hours. So that's how extreme this was. Okay, let's go to, let's see here. Can we go to the current satellite, please? So we'll take a look at what's currently going on. You can see the indication of that system I was pointing out. Here it becomes a nice swirl moving straight from the northwest, so sort of Alberta Clipper type system. That seems to be the only thing going on over much of the CONUS right now, aside from something sitting off California, which will become important later, but this is the main player for us specifically, and you can see right along the leading edge there were some high clouds that moved in, but this is the cold air, this boundary between where we have sunny skies and like deeper low-level clouds. That's going to be our cold front, and you can sort of see it moving southward. You can see also all the snowpack that was here last week is essentially gone. The only snowpack I can really make out because of the clouds is like far north, North Dakota, Minnesota, and then there's still snow in the UP of Michigan, but that's it around our region. And our snow disappeared, so that makes total sense. There is some snow over the northeast still, but we've had a warm up. It seems like we'll continuously have a warm up, so a lot of the snowpack should disappear next coming weeks. What else do I want to point out? I think that's it for the most. So this important thing, we'll take a look at what's going on with this system here. So could we go to the radar, please? So we'll take a look at the radar composite. And you can see, okay, so maybe there is some precipitation on the leading edge of that cold front, but largely you can't really see where that boundary is unless you're in northern Wisconsin. It's producing some lake effect precipitation, or maybe just precipitation. Lake enhanced maybe is a better term, over Michigan, largely just Michigan at this time. That's it though. If you see, maybe if you're in northern Maine, that's the only other place, and then California, where it might be raining or snowing. Yeah.
I'm wondering, what's showing up on the radar in terms of reflectivities over southeastern Minnesota, northwestern Wisconsin.
Yes, sir.
I wonder if that's precip or could it be dust or debris, because it's pretty windy, I think, behind that boundary.
Yeah, it very well could be. We can take a look at the surface map too to see what it might be. I don't think it would be snow at this point either, so it might be dust would be the thing. We are in a drought. This area has been in a drought, so it's very possible that that's dust. Can we take a look at this surface map, please? So sort of verify at the surface, are some of these stations recording precipitation? And we'll see, so looking
Well, there is
around
some,
our
there is
region,
some.
yeah.
Yeah, Minnesota,
So Minneapolis
Minneapolis.
is reporting light rain, there's snow way behind. This wasn't even being picked up by radar, which is interesting. So maybe just very light flurries. You can see heavier snow in the UP of Michigan. The temperature difference is quite stark. You're near 50 southern Michigan, then you go up to the UP and you're 34, this is 21. So that's a pretty significant temperature change right there. Even over us, we're at 53 over 30, very nice day. It's windy, but still pretty nice, and you can see that boundary that I was pointing out in the clouds. You can see where the temperatures fall. La Crosse is at 50, and then I think this is Mankato is at 42. So quite a significant temperature difference, not really a moisture gradient with this passing system until you get far into Minnesota and North Dakota. It seems the moisture dies off, but
And it looks like La Crosse has some light precip too.
yeah, La Crosse does too. Maybe drizzle or something, or rain, but this is a map from February 28th. Look at all these 70s and 60s going all the way up to Illinois, Nebraska, Iowa. This is kind of ridiculous to look at. The only place you're below freezing on this map, aside from the mountains, is UP, Dakotas, and then Maine, where we had snow cover. That's it. Otherwise, we have a lot of just very sunny skies, as we saw from the satellite. This is interesting. Light rain, 60 over 34, and it's clear skies, so you can't always trust every single data point, but, so just something interesting.
Can we go to the southern part of the map, just along the Gulf Coast to see, I mean, the dew points are, you have to go all the way down to Brownsville before you get to,
Yeah,
They have a wind in, but they're.
yeah, so it's warm, but there's not a lot of moisture yet in this portion of the United States. And then could we go to the northeast too? That's where the other place is more interesting.
East and northwest.
Or sorry, northwest, yeah. So you'll see we had just general fog, maybe there's some light precipitation going on, but that's the only other place you'll find any reported weather other than just sunny skies or cloudy skies. Could we look at the 500 millibar map, please? And we'll investigate that system moving over us, and then I'll point out something of interest for the forecast. So before I say anything, pay attention to this going in the forecast. This large trough south of Alaska, pretty extensive in terms of spatial scale. That's going to become an important weather maker for us going forward here. This shortwave, or cutoff low that's sitting off California, is going to make its way into the central United States, but this is the main player for a lot of the weather. If anyone's checked the SVC forecast, this is what you're interested in, not this system right here. We'll see there's generally a ridge over the west aside from this cutoff, so that's been our warmer temperatures. There's a dip and a trough right over us, very small scale, but associated with those colder temperatures. You can see a nice temperature gradient, 18 degrees at, or minus 18 at Davenport, and then it gets close to minus 30 at International Falls. So a nice temperature gradient, cold air advection for sure, right central part of the Wisconsin and Minnesota, right where that system was located at now. Essentially, there's not too significant of a trough ridge couplet with it, but enough to produce a small cyclone as we saw moving over our region. Other than that, here's the other weather maker off the East Coast, so makes sense why most of the United States would be completely clear and sunny skies, because there's just not any systems other than this one that's making its way over us. Everything else is largely over the oceans, so I think that's all I want to point out for this. Could we go to 850, please? So it's not too significant of a short wave at 500. We'll take a look at the temperature structure. So here it's largely just this small cyclone, but there's a nice temperature gradient with it. Places like Omaha are 12 positive, 12 Celsius, and you get up below 0 Celsius in far northern North Dakota. So that's a nice temperature gradient. You can see that band, that leading edge of the temperature gradient kind of matches nicely with the clouds we saw in that leading edge of the cold air. Largely, what I want to say, largely cold air advection just over much of the upper Midwest. If you want to find any warmer advection, you have to go into Canada, it seems, all the way in this portion of Ontario. Other than that, it's mostly just cold air advection. And we're going to be beneficiaries of this cold air advection going forward. You can see that as this system slides southward towards us. What else do I want to point out here? Other than that, there's not anything. It's weekly baroclinic for much of the southern United States. Warm, though, which makes sense why it's so warm. And then here's that system that I'll point out again. There is baroclinicity with it, but it's definitely a nice trough, and it's well stacked, and we'll see that as it makes its way into the United States. That'll become the next weather maker going forward here. This system off California looks like it's even weaker as you go closer to the surface. However, there is a nice temperature gradient with it, so it is going to be a weather maker, but this is the one we want to focus on going forward here.
Yeah, my impression today is that, with a storm of that intensity in the lower troposphere not so far away,
Yeah.
how do we have this kind of windless morning? It's windy between buildings, but walking across campus, it wasn't so windy. That's a really impressive looking storm.
Yeah.
I'm
That's a
wondering,
good point.
I was actually going to ask if we could look at maybe a sounding from Green Bay and another one from, is that Davenport or Eastern Iowa?
Yeah,
Yeah,
Right.
yeah, we absolutely
Because
can.
perhaps the lack of any strong winds might be just due to surface inversion.
Oh, yeah,
And the
yeah.
winds
Well,
haven't
there you
mixed
go.
down.
There you go, yep. So this is Green Bay.
Oh, look at the 50 knot winds at the top of that.
Yeah, you can see, so we have pretty strong winds, but they're strongest right above this inversion here, so
Wow.
that's largely keeping the high winds out of our area. And this is at 7 a.m. this morning.
Right, so if you could bring down just at the top of the inversion, bring that down dry adiabatically to the surface.
Yeah.
That gets you to, what, low 50s, I guess?
Yeah, somewhere around 10 Celsius, I'd say.
Yeah.
Right there.
So, with just mixing and all that, and so that's just before the front comes through.
Right. Which, we are at 53, so
Right.
I wonder if the winds are about to pick up.
Yeah, maybe they are,
Because we
yeah,
mixed
yeah.
out.
Yeah,
So
because
when you get heating and as the sun comes up, this temperature profile, we heat the ground faster than we heat the air above it. So you can imagine this thermal structure, this line right here, this will heat up. Going to the right is warmer temperatures, and so as this heats up, you can mix down the boundary layer. All of this really strong winds can move down with it. And there's not really, this is what's known as inversion. This kind of keeps everything above, what should I say? It holds everything above the surface because it's sort of a lid on the lower troposphere, or just above the surface. So once you remove that lid, you heat the ground, you can move everything that's above that lid down south towards us.
That's a good case. At this time, you have people who are talking about lids with respect to inversions are kind of severe weather freaks.
True.
But and that's fine.
Yeah.
But this is it's the exact same feature, but preserving you from having howling winds at the surface right now.
Exactly.
It's pretty neat.
Exactly, yeah. Can we look at
Davenport.
And then that'll be the last thing I point out
I
here.
think they have a potential to warm up even, far more than
Oh, yeah.
we do.
Way, way up there.
So here,
Right.
just generally their temperature profile was shifted to warmer temperatures than it was over us. So if you mix this down, they're near,
But there's also warmer temperatures to their west and southwest, so they were gonna warm up even more, but they could probably get into the middle upper 50s by the end
yeah,
of
maybe
today.
even the 60s.
Yeah, and then some dust gets blown around.
Yeah,
Yeah.
and look at how dry it is. So,
Here in the bottom two gates is crazy.
yeah,
10 at the bottom and 50 right above it.
right. It's a really strong warmer advection, just in the lowest, 150 millibars. That's your system here, and that makes sense because we saw as we went up, there was largely no system. It was a weak wave, so. That is the current weather. Is there anything somebody wants to see before I turn it over?
I'll just say that next week I'll report on the cold pool. We kind of lost some ground to 8th place last Friday. I suspect it might even be worse at the end of this week, but today's the last day, and then I'll tell you next week what we ended up with.
Sounds good. All right.
All right.
Thanks, Patrick.
Thank you. Thanks, Patrick. So, good morning, or early afternoon. Before we get into the details of the weather coming up, and I'll be honest, I haven't had a lot of time this morning, or I haven't focused a lot of time looking deep into the forecast. But I wanted to say just a couple things about what's kind of happening in the world of weather. As many of you know, I just ended some service with the federal government and the Department of Commerce in the leadership position at NOAA. And many of you are probably aware of the terminations, the firings that occurred over the last day or so, and there are actually maybe hundreds more to follow later on today. And that's been something that's been sort of top of mind for me because it's personal. There are a lot of folks that I know that work within NOAA that, they're talented individuals, they're dedicated, and they have a passion for weather, like many of you, both students and staff and faculty. And it's sort of, again, it's this gut punch feeling because it's something that's going to have a huge impact on our ability as a nation to provide the weather services that are essential for protecting lives and property and ensuring that the conduct of commerce in our country, whether it's transportation, movement of goods, logistics and things like that, have the information they need to be able to work as efficiently as possible. So we do Weather Watch every week during the academic year, and one of the things I want to start off with is, this Weather Watch is really brought to you by NOAA, as well as all the other weather services around the globe that help provide the information that's necessary for us to be able to make forecasts. So the loss that occurred, within NOAA is obviously something that's broader. It's not just NOAA, it's across the federal government. These are firings that are occurring. But for a lot of folks in this building, it's about weather. And if you think about it, hundreds of folks lost positions, over 130 people in the National Marine Fisheries Service, which is a part of NOAA, over 100 in the National Weather Service, and there are others within NESDIS, I think at least 58, and again, more firings are expected between now and the 13th of March. And I don't want to be grim about it, but people wonder what can you do? Obviously contacting your representatives, elected representatives, both in the Senate and in the House of Representatives, and letting them know what you think about these actions, I think is one thing. But it's broad, lots of things that are going on, so focus on something that's meaningful to you, because I think that's where you can probably have the biggest impact in doing this. But when you look at the talent that's been lost from this agency, from NOAA in particular, if you think about it, with these hundreds of employees that have lost their jobs, and again, there's, maybe this will be litigated in the courts, and maybe these will, might be seen as unlawful firings, and so that might actually mitigate some of the losses, but we'll have to see. But that's centuries, if not millennia, of folks that have dedicated the time to study, to train, to actually serve in the workforce. That talent is just lost if they don't come back, right? We're talking about hundreds, if not thousands of work years and hours and, of time that's been spent and invested in learning something, having a passion for this field, and that's gonna be lost. And people say, well, the probationary, they're just, they're new hires. Well, that's not exactly the case. Probationary employment goes back all the way to the Pendleton Act in the 1880s when civil service reform was done. And the idea is that you're sort of still in the hiring process for the first year or two. But it doesn't mean you just arrived at the agency necessarily. It could mean that you could have been hired 10 or 15 years ago and you've moved into another position. And this action that was taken yesterday really was done without, to my knowledge, was done without any deep thought as to, these terminations weren't based on merit, they're not necessarily based on performance, and they lacked, as far as I can tell, any strategy or analysis of what these actions mean. On the front end, for those people that were truly newly hired, right, these are folks much like yourselves, hopefully in the next couple of years, they'll be entering both public service and private service. You have skills that I know I didn't have when I started here at Wisconsin. Python, the machine learning emerging, things of this sort, we just didn't do it, wasn't trained in that. But now these are becoming key tools that are going to be necessary for our nation to maintain the leadership that it has, and leadership that it's seeking in lots of areas of atmospheric science and environmental sciences. And we're losing that. Keep doing what you're doing, keep the studies going forward, and don't lose hope into what could happen next. But it's one of the critical things that I think people talk about, well, you can look on social media and see folks talking about, oh, well, they're going to privatize the Weather Service. And if you think about it, for-profit private weather services, they're companies that exist. They exist to make a profit, okay? They have no necessary incentive to serve the public in the way that a National Weather Service can do this, right? Because one of the key hallmarks of what the Weather Service, what NOAA does, whether it's with fisheries, whether it's with the Weather Service itself, is in ensuring that there is equity in the delivery of services, so that folks in rural parts of Wisconsin have just as much access as folks in urban areas in Madison and Chicago. And private sector doesn't have that incentive or that need to follow through with that. If it doesn't make a profit for them, it's probably something that's going to fall off the edge. The fact that we can show these maps and have these displays is something that, through investments and through law, Congress passed laws to ensure that NOAA's data is easily accessible and is open access. So that just about every single bit of information that goes into the, through NESDIS and through National Weather Service in terms of observations, these are mandated to be out there publicly. So it allows educational places like here at UW for us to get this data and look at it. It allows you to do the work that you're doing on for those of you that are in the research programs doing your theses, your dissertations, undergraduate work, the assignments that you have in class that use real-time or archive data. That, in part, comes from the work of NOAA. Flipping to a different agency, the National Science Foundation, they're experiencing cuts as well. Again, this is across the federal government. And folks like the National Centers for Atmospheric Research and UCAR out in Boulder, Colorado, that manages NCAR. But they have a number of programs like Unidata, which helps feed some of this data from the Weather Service to us. Okay, if things get privatized, our ability to present this data gets limited, or potentially gets limited. We're not going to be able to have these displays showing this. We have to pay for every imagining it's a world in which you have to pay for every observation you have. You can't show radars. I mean, in fact, when John and I started back in the mid-90s, radar data, you could see it on a printed out die-fax map, which probably for most of you means nothing, but it was a printout. And then we working with a local private sector company, we were able to get some of the radar data, and then ultimately that data became easily accessible over the internet, and it just flowed in, and we can produce the radar loops that we were looking at earlier today. So things look grim, and I don't want to be the bearer of sort of bad news about potentially other firings that are coming up. But take the actions you see appropriate. Focus on the things that are important to you. As the former administrator was saying, sort of stay on course and at speed. Use a nautical expression. Things are going to get tough, but there's a future out there for all of you. Private sector may very well be growing. Hopefully the public sector is going to recover, but it's going to take time. But it's going to take folks like you that are in the early stages of your career, or hopeful careers, that you will be able to come and help rebuild this when the opportunity and the time comes. So just sort of keep the faith on that. So let's switch to the current one. We'll start with Pivotal, and we'll just look at some of the watches and warnings that our weather services put out with that forecast link at the top. Someone mentioned that there were some red flag warnings or advisories. If we could scroll down just to see the legend, make sure you're getting this right. Red flag warnings. This is typically when you have strong winds and dry conditions where the possibility of fires rapidly spreading occurs. But we also have wind advisories that are up, winter storm watches and warnings as well. And I guess this flood watch up here might be due to significant melting with the warmth, the recent warmth that's occurring. But you don't see, obviously we have a nice vigorous storm that's going across the northern part of the central part of the United States. But the real weather down the road is going to be coming up, as Patrick mentioned, later in the week. So I don't want to say it's fairly quiet across the country, because most of these advisories are for dry-ish weather, right? With the exception of the the Upper Peninsula and then parts of northern New York State. And this is not because of precip falling, but I think because of lots of melting ice and things like that in rivers that are backed up. That's my sense of that. So we're going to next switch to sort of look at the short-term forecast. We'll go to Pivotal, we'll look at the GFS, and then we'll see that there's going to be a lot of divergence in our forecast going up. So this is a 6-hour map, so this is just at 18Z. There's that fairly decent-looking cyclone, 984, right over Lake Superior, and you can see at least cold thickness advection extends even down to our latitudes at this point, even though at the surface I think we're still in warm advection, but I guess aloft it's cooling off a little bit faster, which is actually, I guess, kind of destabilizing for the warmth at the surface and lower, and upper levels cooling off. The models did correctly forecast that band of precipitation, as Patrick noted on radar, and we saw evidence of that in the surface observations. But it's a fairly nice looking classic mid-latitude cyclone with a nice warm thermal ridge ahead of it, and then, or just south of it, and this broad area of light snow, light to moderate snow to the north. But again, as Patrick was saying, pretty quiet across the country at this point. Let's jump ahead just a few hours and watch this cold advection comes in, and the gradient begins to tighten up just a little bit. Let's go to 12 hours in the forecast. So this is near the beginning of our solstice party event later this evening. So strong northerly winds, cold advection, with this sort of locally strong cold advection, probably broad area of subsidence behind this departing cyclone, or to the southwest of it, and sort of, if you will, severe clear with very strong cold advection subsidence, gusty winds. It's not going to be a pleasant evening walking around, so stay in Memorial Union and enjoy the party. Let's go ahead to tomorrow morning. or tomorrow early afternoon at 30 hours. We're gonna go through this pretty quickly. That cyclone departs, heads off to the east into eastern Ontario and Quebec, 990, so it really hasn't changed much in its intensity. Vast, large anticyclone covering much of the country, and with the exception of some lake effect snow and snow that's sort of synoptically forced ahead of that weather system, it's pretty quiet again across the country. Cold convection, so tomorrow will be clearly colder than it is today, or clearer than it was today during this period. Let's go ahead, we'll just we'll go ahead to Sunday at 54 hours. Really gonna go through this quickly. An anticyclone shifts to the southeast, and the warmer convection begins to start up, so Sunday at least has the promise of being a little bit warmer than it was today. It will be tomorrow. That cutoff that was in the off the west coast of the United States has moved inland. At least the surface cyclone is beginning to develop south of it. Here's a little bit of precipitation that's beginning to start up associated with that. Again, we saw really low dew points until you got down to southern Texas, so it's going to take a while for this air that's flowing northward, and some of it's coming off the high plateau for it to be able to moisten up and actually condense and form precipitation, so it's relatively quiet. The weather, that trough that was out over the Pacific Ocean has now come inland and giving rainfall to parts of California and the Pacific coast. And we'll step ahead one more 24-hour period, and then we're going to begin looking at this a bit more carefully. That cutoff eventually begins to weaken. I believe this is the precip associated with the cutoff. That broader trough that's off the west coast of the United States has now come inland. And we're now going to begin to see the development of a cyclone in southeastern Colorado and in Kansas over by Tuesday afternoon. Let's just go ahead to Tuesday. It's going to take a while to get organized. Yeah. Okay. And that's where we should have probably looked at SPC, and we can come back to that in terms of their outlook. But this cyclone is now beginning to produce. We could probably step forward. Let's go back. Sorry. We'll start at 84 hours and then just step ahead as this begins to develop. So 985, a nice thermal ridge right here. Some snow back in parts of Denver and parts north to Broomfield and into the Boulder area. And then north of this, it's still warm enough. The air hasn't cooled off enough to produce snow, so it's just liquid precipitation. But broad area of warmer convection beginning to set up by the time we get to Monday evening. And so this is, Monday looks to be a fairly nice day. Let's go ahead, another, 6 hours, that's good. Warmer convection continues. So temperatures on Monday night into Tuesday are probably not going to decrease too much. We can look at the actual forecast for temperatures in a moment. But again, strong warmer convection, but very little in the way of precipitation. We're beginning to see the semblance as the cold air begins to come from the west through New Mexico into the Texas Panhandle, beginning of a front that's forming here. You can see the nice diffluence in the surface geostrophic wind as diagnosed from the sea level pressure isobars, and we have the thickness contours here, so there's a cold front that's beginning to set up. And associated with that frontogenesis and the air slowly beginning to moisten up enough we're getting to get some light precipitation. And strong winds and snowfall over parts of central Colorado. 984. Let's go ahead to, so Tuesday morning, 985, still really hasn't intensified. There's that area of precipitation right along the surface cold front that's begun to develop. And we have, again, we're really warm here with thicknesses continuing to increase. And a broad area in the warm sector of this cyclone of some showers that are occurring and maybe some convective precip, again, along this line. To the northwest of the cyclone, really intense precipitation, snow and some, heavy rainfall amounts expected northwest of there. Let's go ahead to, and if there's a question or comment, something people want to look at, we can do that. 102 hours, and then we'll put on. So, what's interesting here, and we're going to begin looking at some different forecasts, because we're going to see that the ultimate track of this cyclone is going to determine whether we get, some models give us half a foot of snow, others give us, that's half a foot. The amount actually on the ground ultimately is maybe 2 or 3 inches because it's been relatively warm and it would be a wet snow. So almost nothing with the track, depending on the actual track of the cyclone. So we're going to have to watch this, but clearly it's going to start as rain at the beginning. And maybe at this point, 102 hours in the forecast, we're 18Z, on Tuesday, we can take a sampling of the model forecast. We'll go first to the icon model, this time to 986 over central Kansas. 988 was a bit more wrapped up and a bit more intense with the precipitation.
Totally different.
What's that?
That's totally different. That looks like the cyclone actually matters. In the GFS, the cyclone's in between a snow band to the northwest and the convective line to the southeast.
Right, so much more interesting looking cyclone. You can even see the much stronger cold advections sort of clearing out through Dallas-Fort Worth area as the fronts move a little bit faster, I think, in this particular forecast. Let's look at the ECWF forecast. I'll also note, ultimately, by the time we get to 12Z on Wednesday, the cyclone ranges anywhere from 971 hectopascal Pascal to, I think, the low 980s. Again, this just looks different, totally different
Yeah, wow.
in this forecast. A bit further to the south and east, okay, it's right along the convective line, and this band of precipitation well to the north is, I think, frontogenetically forced with this sort of diffluent pattern at the surface. And it's, again, the disconnect of the snow, it's this more upslope, I guess, across parts of Colorado. All right, and then finally, the UK Met. I think that was also another widely differing forecast at this point. Okay, that looks a little bit more like, I think, the GFS at this point. But again, the surface cold front really shows up nicely, and we call that a squall line just yet, but this band of precipitation ahead of the front. It's pretty well organized. If we go back to the GFS, and we'll go to 100 and, not 8 hours, 111, just to speed this up a bit. Doesn't really matter. Down to 980. Again, it was GFS headed in central Kansas. It's moved up to 980 just south of Davenport at this point. And strong warm advection, a nice thermal ridge, and I guess a beginning of a trowel-like structure that extends to the north of the cyclone with that warm advection. But you really have to go far to the northwest into northwestern Minnesota, central and northwestern Minnesota before you see anything in the way of snowfall. So that's, again, Wednesday at 3Z, and I just want to make sure we can match these times with the other ones. So we're looking at Wednesday at 3Z. Let's just again take a sample of the different solutions. Icon first.
Whoa. That's so
Slower
Zero
system.
Z,
That's 0Z. Okay, so it's off by about 3 hours. But that cyclone is a little bit further to the south. These hasn't really moved much. It's moved a little bit to the north. But again, it also has this, again, conspicuous thermal ridge that extends all the way around to the north side of the cyclone. And we haven't even gotten precipitation yet. That's the other sort of manifestation of this. Nothing's actually happened yet here. It could actually be a nice day on Wednesday without precipitation just yet. And the ECWF, we'll just look at these three. The ECWF at nearly the same time. We'll be able to match up this time. Actually looks a little bit more like the icon at this point, but maybe some light precipitation having reached our area at 984. Let's go to Wednesday at 12Z in the GFS. I think this is when we see the break. Wednesday at 12Z. Now it's intensified to 971. So that's about 10 millibars in the last, I guess, 9 hours. The last map time that we looked at for this, as it's now just southeast of Madison. It just, this precipitation, the warm air is wrapped, really, if you look at the thermal structure, that's wrapped all the way around the cyclone and to the southwest. We're getting cold advection, in fact, from the southwest. It'll be colder to our south and maybe snowing while we're still in this warm seclusion with the above freezing temperatures throughout the profile. At this time as well, now the snow has made it into eastern parts of Minnesota and western Wisconsin. Let's again look at the differences in solutions. We'll go to icon next. So this was just southeast of Madison, a little closer to Janesville. Icon has it well to the south with just a little bit of snow on the north side of that. 991, so 20 millibar difference in the forecast. So that's one thing. And then ECWF, at the same time, 983,
It's a bigger snow event for us. now.
But this is the forecast that gives us, I think, 6.1 in terms of total accumulated precipitation. I haven't looked at this or done any diagnosis in depth to see which one is more believable. The GFS has been at least consistent with its intensity of the cyclone and the track. I think the track has actually edged a little bit further to the north. The ECWF, I think, has actually been trending a little bit further to the south. But where is the minimum and sea level pressure? I mean, that's where it's noted here, but it could even very well be a little bit further to the north. It depends on, I guess, where the forcing is for this.
Have you looked at the AI UW-AOS that's operational now?
Yeah, let's take a look at that. I don't know if it's run just yet.
It's a 6C run, yeah.
Right, so 6C run.
Yeah.
Yeah, 6C run. Yeah, so another thing that's happened, weather news that's really interesting, is that European Center just earlier this week, we can look at, no, that's the precip. But there's a sea level pressure. They just made operational instead of experimental their AIFS version 1, which is an artificial intelligence version of their model. I am not certain.
It's the same time.
This is the output is, we're getting the latest and greatest version of this model, but they've seen that the statistics in terms of performance still outperforms the IFS, so this AI-based model is still running well ahead of the other operational model, which is the physics-based IFS model, which is ECWF's sort of golden sort of flagship model that's done quite well in terms of anomaly correlation and things of that sort. So they've operationalized this. I don't know if this is the run. This is the 6C run, but it has a different forecast. If we actually go to the 6C version, we got to log on. All right, it's a weird password to do that. So let's look at the 0Z version of this, of the IFS. You can keep that. First, let's just so we can match things up. So the 0Z, see what the track was. 982, so it's a little bit deeper, but then if we look at the ECWF at the same time. So last night's ECWF at 0Z, it's actually kind of roughly in the same location.
Different trough structure though.
Right.
I think that the AIFS has more snow for us.
That could very well be the case, yeah. We could look at the precip amounts for that. I don't know if it has snowfall on this one or not. Oh, you can precip rate and accumulated precip, let's say 24 hours. Yeah, I think you're right. And then we look at the AIFS, it's a mouthful to say.
Yeah.
Yeah, so it's wetter. So
Roughly
maybe you could say
50
that,
times more.
could be that the AIFS and the GFS are a little bit closer in terms of track
Yeah,
and
yeah.
precipitation amounts.
And I think in this case, the structure looks kind of like an elongated trough with a lot of frontogenetic activity to the northwest of the trough axis.
Right.
They both share that.
So anyway, we have this sort of bifurcation and forecasts that are going to occur as we get into this event. The ECWF, again, in terms of accumulated snowfall, we can go to the bottom of this. I don't think we have the snowfall for this, but we'll see.
Hey, 24 hours.
24 hours.
Oh, yeah.
John, come on, please.
All right.
Yeah, we can even zoom in a little bit, but this will be useful to just do this, go to regional.
Oh, yeah, 5.6, right on top of us.
5.6, and then the 6C run.
Ooh, 6.3.
6.3. I'm no fan. And we can go to,
Sounds
look
like
at
suddenly there's an enormous skepticism.
Icon. Let's look at everything. It'll probably snow, but the question is, John, we'll get to this in just a moment. Okay, this is 24-hour from the icon. John?
Well, it's been wrong all along. No, it's definitely a huge divergence, and the ECWF looks like this for a while, but it looks more like it's AIFS at the end, even
So,
though it's not as good as
If you look at maps of this sort from the icon model, is that iconography?
Yeah, it is iconography,
Okay.
and it's blasphemous in some churches.
All right.
It is, that's part of the schism between the East and the West. You guys
Okay,
have-
GFS. Same, well, really looking at the same time now.
Go to 126.
I'm sorry?
Go to 126.
126, okay.
There.
So it looks like the timing for snowfall is also different.
Yeah,
in these
very
as well. If we go to, let's go to this total, because nothing's gonna happen before. And go
Yeah.
to bless you, one.
Thanks. Well, I know which one I want.
138, it's got a 138. Yeah.
Yeah.
This isn't bad, right?
Yeah.
And that's 60, and let's look at the 12Z.
All this bring it on talk last week, I think that's kind of faded into the background.
Yeah, this is with the big wrap up and the snow.
I won't stand for 7.5 at Rockford,
Look at that.
2 at my house. I won't.
It's not even 2, is it?
Yeah, probably.
Oh, yeah, 1.3 again. Right. Okay. And ECWF for 12, from the 12Z run.
Yeah, see, that's better.
Degrees of difference in
It's
interpretation.
enormously different, and it's not that far out. It's really, what, 5 days?
But I mean, this is really an interesting case of sort of where the forecast actually fractures is at the handling of the trough that's, again, now well off the west coast of the United States. People say, well, it hasn't been sampled by the radio sons, but we do have satellite observations which are assimilated into models and should help improve the forecast. But, this is a curious, change in structure of the storms in terms of the track and precipitation amounts, and we'll probably come back and look at this on Friday.
Yeah, it strikes me that I'll bet you there's big differences in the upper levels too. I bet you that the 500 millibaud GFS feature stays a little more coherent and isotropic, and then it's kind of stretched out in all of the other solutions from Europe,
Right.
including ICON, which stretches it out maybe more zonally than meridionally, and the ECMWF seems to go southwest to northeast.
Right. I hate to do a discussion without any sort of diagnostics, but just today has been a little bit short. But the other thing I want to do is just show, since I promised this last time, I will do it every week until the end. We're going to look at 700 or 600 some hours out into the forecast. And this is this is on the that loop that you made, Pete. Okay, please. So I've saved from Friday of last week through 0Z last night the forecast valid, surface map forecast valid for the weather watch just before spring break occurs. And then we'll look at, this is the CFS forecast, the climate forecast system from NOAA. We're going to look at every 12 hours when this is run, how the forecast has varied. You'll see, talk about forecast fracture and things going back and forth, windshield wiper or whatever affecting the forecast. Things are changing a lot in the forecast, but at the end of the, this loop that ends with the forecast that was initialized just last night at 0Z, things begin to seem to sort of become more zonal pattern. So let's go ahead, 12 hours, this is the one. So these are all maps from the same model, valid at the same time. You'll notice the forecast length changing. And you just keep stepping ahead with this. Do we get precip? No, it's warm. No, it's cold. No, it's okay. It's kind of in the middle. It's Goldilocks weather. And then more convection, getting cold again. Looking again, these are the ones that are initialized, and it looks kind of wet, perhaps. And then the flow becomes more zonal. And the last one, you can sort of see this sort of picture right here.
That's the weirdest forecast for precipitation I've ever seen.
So it's one of those, if you've never seen a forecast before, and
Yeah.
someone said, John, I made a model, here's my output.
No, go back to the drawing board.
So we'll look at this. Again, this is more just out of curiosity. I mean, at what point do we actually sort of lock into a forecast that will be reliable? And I'll follow this up every Friday until we get to just before spring break. We'll get into the GFS, much shorter time scale, better resolution of the model. GFS has a higher resolution than the CFS. And we'll be able to see as the forecast length decreases, do we see less variability in the forecast. One thought that I had, which would be kind of interesting, I don't know if anyone's done this, but it's kind of an obvious thing to do. Those of you that are taking sort of the sort of advanced statistics class, might have an interest in looking at this. We do get this data gridded, but it'd be interesting to take some of these forecast fields from the various models and then do an EF analysis of what the final state looks like, and to see are there dominant modes of variability or structure that emerge from the forecast, all out at the same time, but at different, across these different lengths.
Yeah.
Just kind of a curiosity. And obviously, this is a single deterministic forecast. You'd want to look at an ensemble of these, et cetera, but this is just something I always find interesting is when we have a key weather day or key event or something about to happen, just to see how the forecast evolves before that. In this case, just before spring break. Anyway, thank you for your attention. Thank you, Patrick, for a wonderful early discussion. Thanks, Pete, for driving and helping get this loop put together after we collected the images. and have a wonderful weekend, everyone.
Yeah, thank you, Michael. Thanks, Pete.